everybody are doing well. As you have requested, I have come up with the most interesting and the most requested chapter, that is exploring mixtures and their separation. And before I start this chapter, I would like to ask you one question. How are you guys enjoying this class 9 new syllabus series? Already the first chapter is over, exploration is done, cell chapter is done, motion chapter is done. So I was watching those videos. Yes, so they are also put up as cards in this video. Please go and watch if you have not yet watched. Okay, they have come out amazingly well. And if you are enjoying all these videos, type enjoying in the comment section, and at least if you have got a benefit of just 1% from the video, please hit a like button so that it will reach students like you. Okay, yes. And coming to the chapter, first you all must understand what exactly we mean by mixture here. Okay, so there is a word called mixture, isn't it? So what exactly we mean by mixture? So the moment we hear this word mixture, we remember of the food that is available in a bakery, isn't it? Yes, that's a mixture. The same meaning, even it applies for chemistry also, right? So the eatable mixture that we get in a bakery contains what? It's a combination of so many different items, right? So you have some items which is of round, and you have some items which is like rod like, and you have different stuff mixed together, and that's why you feel it very, very tasty. Same thing here, mixture is nothing but it is a combination of two or more substances. Okay, so what is a mixture? Combination of two or more substances, we say. So what do you mean by substances in chemistry? So many students would ask me, ma'am, what is this word substance? Substance here nothing but component. Okay, or component is nothing but parts. Okay, or it can be items. You can also say it as items. Okay, so when two or three different types of items or substances or components when mixed, then that is called as a mixture here. Okay, suppose if I take a pure water, I'm taking a pure water. Actually, pure water is not considered as mixture in chemistry because it's already pure. But suppose if I take milk here, okay, so in a beaker I am taking a milk. Can you call milk as a pure substance? No, milk can be a best example for mixture here because the milk will contain some amount of water in it. It has got some amount of milk protein in it, and this also has got some amount of fat in it. Protein is a chemical, different kind of a chemical. Fat, different kind of a chemical. Water, different kind of a chemical. So different kinds of chemicals when mixed together, then that is called as mixture. Okay, so hope you understood. Now the entire chapter is all about studying different kinds of mixture and how to separate one component from another. Okay, so it's a combination of two or three pure components, I said. So now if you want to separate one from another, we keep using different techniques. Okay, so in a chapter, what are we going to study is very simple. We study different types of mixture. Okay, so different types of mixtures, and then their separating techniques. Okay, separating techniques. That's it. So there are different types of mixtures, and different mixtures are separated using different separating techniques, guys. Okay, all of that we are going to study one by one. So now coming to the mixture types. What are the different types of mixtures here? Okay, so majorly speaking, mixtures are of two types. Mixtures are classified as two types. One is homogeneous mixture. Okay, the other one is heterogeneous mixtures. Right? Okay. So now this classification is based on, it is actually based on uniformity. Okay. So mixtures are classified based on different concepts here. So majorly in your textbook you have this classification mentioned, and this classification is actually based on the uniformity. That means the different components or the different items, how well they got mixed with one another. Okay, how much good friendship is there between the different parts or different chemicals is what we call uniformity. Okay, so how well one component got mixed up with another is what we call uniformity. So based on uniformity, mixtures are classified into homogeneous mixture and heterogeneous mixture here. So now if I have to show you the examples of homogeneous and heterogeneous mixture, look at here. Okay, so this is actually a sugar water. Okay, sugar water or salt water, whatever. And this is sand water. Okay, so what are the two components which are there in this solution? You have sugar, water. Okay, so these are the two different chemicals that are there, and one chemical got mixed up with another chemical so well, isn't it? So here what do we say the definition of homogeneous mixture as? It is that mixture. Okay, this is the definition that you all can write, guys. It is that mixture in which components are uniformly distributed. Very important. What do you mean by components? The different parts which are different chemicals which are there in a mixture. So components are uniformly, okay, constantly, uniformly distributed. Okay, so uniformly, the meaning can be the other simple meaning for uniform can be equally. Okay, so they are equally distributed. Suppose when you start drinking this sugar water, you know, the water that is there on top taste equally, okay, with the water that is there at the bottom of this glass, isn't it? Every sip will have equal taste. Okay, it is not that the sip that you take it from upper portion of the glass is more sweeter than this, or this portion is more sweeter than this. No. Okay, concept is not like that. Every sip that you drink from this glass will have an equal taste. What does that say? It says that sugar got very nicely mixed up with water. So there is a very, very thick friendship between sugar and water everywhere, okay, in this glass of sugar water. So that is what we mean by uniform distribution. Okay, so whereas if you look at the sand and water, look here on the upper portion of this beaker, you have more water. So here you have more water, and at the bottom all your sand particles got settled, and here you have got more sand, isn't it? Is there an equal distribution of both sand and water everywhere in the portion of this beaker? No. It is different. Okay, so here more water, less sand. Here more sand, less water you have, isn't it? So this is not uniform distribution. Okay, so what is the definition of hetero? Hetero means different. Homo means same. Everywhere same composition of the components you will have. Okay, so hetero means different. Okay, so how do you define here? It is that mixture, okay, in which components, very simple guys, components are not uniformly distributed. That's it. Not uniformly distributed, right? So what is the difference between the definition of homogeneous mixture and heterogeneous mixture? Here it is uniformly distributed, but here the components are not uniformly distributed. That's it. Okay, so hope you understood the idea of homogeneous mixture and heterogeneous mixture. So now, okay, so these two are one type of classification of mixture. Like I already said, homogeneous and heterogeneous are classified based on the uniformity. Okay, but mixtures are also classified. Okay, I'll show here only. Mixtures are also classified, based on size of component particles. Based on size of component particles actually. Okay, right? Say, for example, in this picture that I have shown, sugar is one component, water is another component in this mixture. Okay, so sugar and water have got a different sizes. Sugar has got one size, so sugar particles size is different, water particle size is different. So here the size also has synced so much. The sugar particle size, water particle size also matters whether they are mixing it well or not mixing it well. Okay, and if you look at this mixture, look at the sand particles are really bigger than water particles. Okay, so the size difference between the sand particles and water particles is actually very, very huge. Okay, so the size of the particles also matter a lot to talk about the properties of mixture. Okay, so different mixtures behave in a different way, they react in a different way. Sometimes it is because majorly depends on the size of the component particles. Okay, right. So based on the size of component particles, mixtures are divided into three types, guys. This classification is also very, very important to understand, though they have not directly mentioned in a NCERT textbook, but please understand mixtures are also classified into three types, but on what basis? It is based on the size of component particles. Okay, so what are the three types of mixtures? Solutions, okay, solutions, then colloids. So we have another kind of mixtures called colloids, which are very, very important. And finally, we have something called suspensions. Okay, so everybody write in the comment section what are the three types of mixtures based on particle size, based on component size. It is solutions, colloids and suspensions. So in solutions, the particle size is very small. Okay, so size is very, very small. Okay, whatever the particles that are there in the mixture, their size is very, very, very small, guys. Okay, and here in colloids, the size is intermediate. Size is intermediate. Okay, so it is neither small nor big. Okay, that is what we mean by intermediate side. And suspension, the particles, the major component of the mixture is really big. Okay, so big size. Size is really very big for some of the particles which are there in a mixture. Okay, so for solution, if I have to give an example, your salt plus water, okay, your sugar plus water, right? So all of this can come under solutions. Okay, so like I have shown in the picture, say this all homogeneous solutions, homogeneous mixtures, all of them actually can be called as solutions. The particle size is very, very small and one particle can easily get mixed up with the another particle. Okay, so these solutions are there, they most of the time they are homogeneous in nature. That means since all the particles are very, very small, they can nicely get mixed up with one another and forms what kind of mixture? Homogeneous type. So they will have what nature? They will have homogeneous nature. Okay, yes. So now colloids and suspensions. So both these colloids and suspensions are there, so they will come under heterogeneous. Okay, say blood is an example for colloidal, the human blood is the best example for colloidal solution. Even milk is an example for colloidal solution. Okay, so these colloidal mixtures will have a very different properties. All of that we will see it in the chapter. Okay, and for the suspension, like your sand plus water mixture that I have shown, no, that can be an example for suspensions. Okay, so hope you understood the difference between solutions, colloids and suspension. So solutions will behave as homogeneous type and colloids and suspensions will behave as heterogeneous type. And try to remember few examples under each category that I have given. Okay, so this is all about the classification of mixture. Okay, so this topic as it is not there in textbook, but look at the activity that is there in your book. Okay, let me show you your NCERT book here. Look at this activity that they have mentioned here, guys. So they have taken 3 solutions here. Okay, they have labeled this beaker as A, and in beaker A, this is just, what is that? They have mixed salt plus water. So this is a mixture of salt and water. Okay, and beaker B is a mixture of chalk powder and water. Okay, chalk powder and water. And beaker C is a mixture of what? Group C, add few drops of milk and water. Yes, so this is a mixture of milk and water. Okay, say this person is holding a laser light. Okay, he is passing a laser light through the solution, actually through the mixture. Okay, I'll not use the word solution here as of now. I'll use all the 3 as mixtures. Okay, so he is passing this laser light through this mixture, which is a salt plus water. Can you see the laser light through the solution? So that pink color laser light, directly you can see its dot here, but you can't see the path traveling through the mixture, isn't it? So actually salt and water combination, this is an example for solution. What kind of mixture it is? It is an example for solution. So any clear solution, any pure solution, through which when you pass a light, the path of light passing through the solution is not visible. Okay, but look at chalk and water. This is actually an example for suspension. What kind of a mixture it is? It is an example for suspension. Chalk powder is really, chalk particles are really a bigger particle. Most of the chalk powder it went at the bottom and it got settled. And when this person has passed the laser light, you can see the pink color even in the mixture, but it got spreaded too much, isn't it? Right? So you see a very, very light pink color line passing through the mixture, isn't it? So that is the suspension. That is how the suspensions actually behave as. But now look at the third beaker, guys. So if you look at the third beaker here, right? See, the laser light path is clearly visible inside a mixture. Okay, so even from your eye, you can see the path of light inside the mixture passing very nicely. Okay, so actually milk and water is an example for colloids. So colloids have got this beautiful property actually. Okay, so their properties are very different. They behave differently, right? So when through the colloid, you take any colloidal solution, when you pass a light, you can beautifully see the path of light crossing through the mixture, passing through the mixture. Actually, that effect, that property is called as Tyndall effect, which you will study later in the chapter. I will explain what is Tyndall effect, because the situation has come, I have used this word. So this phenomena, clear clearly you can able to see this path, no, that property, okay, that nature itself is called as a Tyndall effect. So Tyndall effect is a very good property of what kind of mixtures? Colloids. Okay, so this activity itself tells you that mixtures are of different types, different mixtures behave in a different way. Okay, solutions behave in a different way, suspensions behave in a different way, and colloids behave in a different way. So out of these three, which one will behave as homogeneous, which one will behave as heterogeneous? Solution is a homogeneous type, whereas suspensions and colloids are heterogeneous type, and colloids also heterogeneous type. Okay, right? So this is all about different types of mixtures, and different mixtures behave in a different way. Now, slowly we will go and understand the first variety of mixture. Okay, I told you mixtures based on the particle side, based on their behavior, I can say. Based on their behavior, they are classified into solutions, suspensions, and colloids, right? So first we are understanding everything about solutions type. Okay, solutions kind of a mixtures is what we deal in the chemistry labs most of the time. Okay, so whatever the chemical combinations that we are seeing in a day-to-day life, all of them come under this category called solution. So first let us understand what actually we mean by solution. Okay, all of that, how do we separate one component from another component from solution, all that we will try to understand now.
So now let us understand everything about solution. Okay, so solution is a homogeneous kind of a mixture. We all have understood so far. Solution can be of so many types, guys. Okay, so understand this. So there is something called binary solution, ternary solution, and there is something called quaternary solution. Okay, so these are different kinds of solution. Okay, and what do you mean by binary solution? Where the mixture or a solution which is made up of two components only. You will find only two components which are chemically different. Say for example, salt plus water is an example for binary solution. Sugar plus water is an example for binary solution. So any solution which has got only two components is called as binary solution. So you can guess what might be the ternary solution, right? So ternary solution is the one which has got three components in it, three different substances in it. Similarly, quaternary solution is that which has got four components in it or four substances in it. But in our chapter, we limit our study only to binary kind of solutions. Okay, say we only see the examples where you have only two components or two substances mixed together, and these components, whatever the two components that are there in binary solution, those components both can be solid. Okay, or you know, one solid component would be there and one liquid component would be there. Okay, or both can be liquids, both can be gases, liquid and a gas combination, solid and a gas combination, anything it can be. Okay, so the physical nature of components can be anything. It is not that both should be solids or both should be liquids or one should be solid, one should be liquid. It is not like that. But commonly seen combination is this only, no? Okay, salt plus water. So salt is a solid, water is a liquid. Sugar plus water. Sugar is a solid, water is a liquid. Okay, so most commonly seen example is this. Okay, it doesn't mean that solution means always a solid which is there in a liquid. No, it can be two components, both of them can be solid, both of of them can be liquid, okay, both of them can be gases, one solid, one gas, one liquid, one gas, one solid, one liquid, anything it can be, okay. So understanding this idea is also very important.
Okay, so now we understood, right? So now I said binary solution. So we are not discussing anything about ternary here and quaternary here. Okay, so coming to binary solution, I said you will have two components. Binary solution is the one which simply can be called as a solution here. Okay, because we are only talking about binary solution, no? So that I simply call it as a solution. So here, as far as 9th class concerned, the moment I say solution, it is only the binary solution. You will have two components. Okay. So what I said, you will have two components here. Okay. And we have given those components a special names. Okay. So one component is called with the name solute, the other component is called with the name solvent. Very, very important. So out of two components, one is generally called as a solute. Solute can be anything, solid, liquid, gas. The other one can be called as a solvent, that also can be solid, liquid or gas. Okay, fine. So now, which component is called out of two, which is called as a solute, which is called as a solvent is very, very important to understand. So listen carefully. Okay, the substance or the component, very, very important, the substance that dissolves. Okay, so that dissolves is called as a solute. Or in other words, this is what the definition mentioned in your textbook. So I have given here. But if you want to understand it in a simple way, just apply this trick, guys. Okay, the substance which is there in a small amount. Okay, so in a solution, the substance or the component, okay, very important, understand, and also type this definition in the comment section. Okay, so the substance which is there in small amount, that is called as a solute. Okay, say for example, I have taken a beaker of sugar solution. Okay, so how did I make this sugar solution? Say for example, I have added 1 spoon of sugar. Okay, this is 1 spoon. Okay, maybe I have added just 5 grams of sugar into 100 ml of water. Okay, so now there are two components here. One is sugar, the other one is water. Okay, which one is there in small amount? Obviously, sugar is there in less amount or small amount. Water composition is very, very high. Okay, so which one is there in large amount? Water is there in a large amount. So here, sugar is called as a solute, the one which is there in a large amount. Okay, so the component in large amount, okay, that is called as solvent. Okay, very, very important.
Okay, if the concept is crystal clear about solute and solvent, type crystal clear in the chat section, and if you have not liked the video yet, hit the like button. So now you understood what do you mean by solute and solvent. Next we will try to understand very, very important concentration of solution. Okay, so this is very important to understand and very, very interesting also. Okay, understand it carefully. Don't mug up the formulas. Understand the real meaning behind it. Okay, if that is okay, type okay in the comment section. Okay, yes. Before even I begin to explain this topic, I will give you one example. Okay, say you have 2 lemon juices. Okay, so what am I taking here? I am taking lemon juices, right? So this is lemon juice number 1 and this is lemon juice number 2. Okay, and this lemon juice is very worst to taste. Okay, so the moment I sipped this lemon juice, I felt too salty. Okay, and I felt it is too sugary, and I can't even define its taste. Okay, but when I tasted this lemon juice, it was perfect. Okay, so I felt it like drinking again and again. So I have asked a person who have prepared this lemon juice, and I just asked one question. Oh my god, this is tasting so bad. How much amount of sugar you added? Say he gave me 1 glass full of lemon juice. Okay, definitely I would ask him, how much of sugar did you add? Okay, to this 1 glass of solution. In this 1 glass of solution, how much amount of sugar is there? How much amount of salt is there? How many lemons did you squeeze? You know, this is what is very important, right? If you want to make a perfect lemon juice, you know, maybe half a piece of lemon, or 2 spoons of sugar, 1 full glass of water, and just a pinch of salt might be enough to make that perfect lemon juice. So here, how much amount of each ingredient that you are adding to make that 1 glass of lemon juice is very important. That is what we call concentration. So what is concentration? How much amount of ingredients that are there in a particular solution is called concentration of a solution. Okay, and you know what, we deal with lot of solutions in day-to-day life in chemical laboratories. Say somebody gave me a solution, okay, somebody gave me some solution where 2 components are mixed, and it's very important to know how much amount of each ingredient is there in that particular solution. If you don't know how much amount is there, it leads to lot of confusion. Okay, right? So how you will define the term concentration here? Okay, so now I am giving you the definition of concentration. Okay, so it is all about how much amount. So concentration is all about amount, quantity. Okay, so how much amount of solute is there in given amount of solvent. Okay, very important. This is called concentration of a solution. Say for example, your lemonade, 50 ml of water is fixed. Your solvent is water, 50 ml. In this 50 ml of lemon juice, how much of sugar is there? How much of sugar is there? How much of salt is there? How much of lemon juice is there? Okay, so all these are solutes. Okay, they are there in small amount. Which is there in larger amount? Water. So your water is a solvent. So in this fixed amount of water, how much of sugar is there? Very important to know. How much of salt is there? Very important to know. How much of lemon juice is there? Very important to know. Okay, so concentration is all about how much amount of solute dissolved in given amount of solvent is called as a concentration of solution. Now this concentration can be expressed in different ways. Okay, so now what we will understand is different ways of expressing concentration. So what do you mean by expressing concentration? Why should you have different ways of expressing concentration? I'll give you one interesting and funny example here. Suppose you got angry, okay, and your anger you will express in different ways, isn't it? You might express your anger by shouting at someone, or you will express your anger by sitting and crying, or you will express your anger by throwing the stuff which is there around you, isn't it? So here emotion is single. What is that emotion? Anger. But how are you expressing it out? You are expressing it in different ways. And when do you express anger? By throwing.
You can express anger only when you have certain things around you. You will express your anger by throwing. Suppose if you don't have anything to throw, okay, will you be able to express your anger by throwing stuff? No, right? And when somebody is there in front of you, you express your anger by shouting at them. Suppose if nobody is there and nothing is there to throw also, then you will express your anger by sitting and crying, isn't it? So just like that, depending on the different situations, okay, so very important, depending on different situations, okay, depending on different situations or depending on different types of solutions, okay, depending on different types of solution, okay, different expression terms are there, okay. We express concentration differently. What is concentration? The amount of solute, how much is there in how much amount of solvent. So that is expressed differently depending on different types of solution here. Okay, right? Say for example, when solid is mixed with another solid, we use one concentration term. When solid is mixed with a liquid, another liquid, if solute is a solid, solvent is a liquid, then we use another concentration term. Like that, depending on the different types of solution, just like depending on the availability of things around you, people around you, right? You express your anger. Like that, depending on the different types of solutions, okay, in different situations, we keep using different expressions to express the concentration of a solution. Okay, so now what are the three ways? So in your textbook, there are three ways of expressing concentration. Okay, so let's understand the three ways. Actually, you have so many ways of expressing concentration here. Okay, so many concentration terms are there. You will study in the higher classes. But as far as your chapter concerned, there are three methods of expressing concentration. Okay, so number one, you can express concentration with the help of mass by mass percentage. Mass by mass percentage. Okay, right? So, mass by mass percentage can also be represented with one symbol or one sign, you can say. That is, you can express by W percent, or you can express it by M percent. So, what do you mean by W here? Weight, mass. Okay, so when do you use this mass by mass percentage? You know, when the solution has got both components solids. Okay, so if a solution has got all components, so it can be two components or more than two components. If all components are solids, okay, if all components are solid, two or three solids got mixed up with each other, some solids less amount, some solid more amount, but two or three solids when got mixed up with each other, that point of time, if you want to know how much of solute is present in total amount of solution, okay, then this concentration term is used. Okay, and the next concentration term here is you know, mass by volume percentage. Mass by volume percentage, guys. So it can be represented as M by V percent. M for mass, V for volume. So this kind of concentration term is used for those solution where one component, okay, it is used for those solution where one component is solid. One component is solid, okay, the other component is liquid. So the other component is liquid. So usually when solids are dissolved in liquid like lemon juice, salt solution, sugar solution, if you want to know how much of sugar is there in this much amount of water, how much of salt is there in this much amount of water, okay, so in those situations, solids when present in liquid component, that point of time, mass by volume percentage term is used. Okay, you should know when does these terms used actually. Okay, and coming to the third category, it is volume by volume percentage. Volume by volume percentage, guys. Okay, so how do we express this volume by volume percentage? V by V percent we say. So here when all components are liquids, so this is used when all components are liquids. Okay, solute is liquid, solvent is also liquid. You can have 2 components, 3 components or 4 components, but all are liquids. Then we use this particular concentration term to express the concentration. Okay, so hope you understood the 3 methods of concentration terms. So now we will understand how do we define this, what is the formula, how to calculate, how to understand everything one by one. Okay.
Guys, if I have to show your NCERT textbook, look at here. How did they define mass by mass percentage? Okay. So, and you know, mass by mass percentage is used for the powders. You know, as I already told you, when 2 or 3 components mix together and all the components are solids, okay, usually the powders, isn't it? It can be ORS powder, right? So in your textbook they have given, right, the person who has discovered the ORS powder. What is a ORS powder? Oral rehydration solution, isn't it? Right? ORS powder. What do you have in ORS powder? You'll have some amount of sugar, right? You'll have some amount of salt, and you will have some amount of minerals. What do you mean by minerals? The elements like magnesium, sodium. Okay, so all of those elements also you will find in ORS powder. Okay, and it's very important how much amount of sugar should be mixed with how much amount of salt and how much amount of mineral should be there. Okay, all of that is very, very important. Okay, so like ORS powder, and you have so many powders available in the market. Milk powders are there, talcum powders are there, detergent powders are there, where so many chemicals, so many components are mixed with one another, no? So to express each and every ingredient, how much of it is there in the total amount of powder, this mass by mass percentage is used. Okay, right? And before that, I would like to tell you one thing for all of you guys. Okay, so whenever you write solution, no, your solution is nothing but solute plus solvent. Okay, so the amount of solute, when you combine with the amount of solvent, then it becomes a solution. So this particular relation is very, very important to understand. Why did I tell you now? Because in the formula and all we use that. Okay, so now if I have to tell you, for all of you, what is mass by mass percentage? It is nothing but the amount of, so very important, listen carefully. Okay, so it is the amount of solute present in 100 grams of solution. I told you solution need not be solid mixed with a liquid. Solution need not be a liquid. Okay, solid mixed with solid also is called as a solution only, isn't it? So here this milk powder is a solution. It is a solid solution because all the components, the fat, sugars, fiber, protein, sodium, all of them are solids. So I mixed together and I got this packet's weight is 100 grams. That means the solution has got a weight of 100 grams. In this total 100 grams of powder, how much of fat is there? How much of sugar is there? How much of fiber is there? That is what we call it as mass by mass percentage. Okay, so if I have to find out how much of fat is there in this particular 100 grams of solution, how do I find out? You can find out with the formula. So the formula for mass by mass percent is mass of solute Okay, mass of solute divided by total mass of solution. Total mass of solution. Solution means what? All the solutes plus, yes, all the solutes plus solvent. Okay, that if you combine, you get the total mass of solution. Multiplied, we are calculating percentage. No, percentage means always it is multiplied by 100. Guys, this is the formula for mass by mass percent. Okay, so suppose look at here, they have given a wonderful example in a book, guys. Okay, see here, they have given one example in a book. Look at here, if 10 grams of salt is dissolved in 90 grams of water, so which one is a solute here? The one which is smaller in amount. Okay, see, 10 grams is small, 90 grams is big, so here salt is a solute. Okay, and this 90 grams of water is there. No, this is your solvent. Okay, so they have mixed 10 grams of salt in 90 grams of water. Calculate the mass by mass percent of the solution formed, they are asking. So what is the mass of salt? 10 gram. What is the mass of water? 90 gram. Okay, so what is the formula that you have? Okay, so what is the formula that you have here? Right, so let me, mass of a solute, right, mass of a solute divided by mass of solution, okay, multiplied by 100. What is the mass of solute they have given? 10 grams. What is the mass of solution? 90 grams. 90 grams is actually mass of solvent, isn't it? Right, mass of solution means, mass of solution means it is mass of solute, right, plus mass of solvent, guys. So whenever you take the value in the denominator, no, it should be the mass of solute plus mass of solvent. Be very, very careful. If you put 90 here, no, it is wrong. Okay, 90 is mass of solvent, so you want mass of solute plus mass of solvent. That means 10 plus 90. 10 plus 90 is how much? 100. So 100 you have to take it in the denominator, multiply by 100. Okay, 100 cancel. So 10% is the mass by mass percent of this solution, guys. Okay, right? So hope you understood. See, 10% m by m that you got here. Okay, so 10% m by m means what? 10% m by m means what? It means 10 grams of salt is present in 90 grams of water. Or you can say 10 grams of salt is present in 100 grams of solution. Meaning is same, guys. Okay, so whenever I write the words 10%, okay, say whenever I write the words 10% m by m means what? Its meaning also you should understand. It means 10 grams of solute is there in how much amount of solution? 100 grams of solution. Okay, or what does it also mean? 10 grams of solute is there in 90 grams of solvent, that is water. Here in this case it's water. Okay, so you should also know, whenever they mention like this, you should also know the meaning, guys. Okay, right. So now one question for all of you here. What is the meaning of 2% m by m? Tell me, guys, 2% m by m means what? What does it mean? How much amount of solute is there in how much amount of solution? And also tell me how much amount of solute is there in how much amount of solvent. Okay, right? So I told you the meaning of this in both ways. Like that, in the comment box you are telling the meaning of 2% m by m in both the terms. Okay, so that is all about m by m term. Okay, so now coming to Yeah, mass by volume. So when does the mass by volume is used? Mass by volume is used when a particular solid is dissolved in liquid. Okay, look at here. It is vinegar, acetic acid. Okay, so acetic acid is actually solid. So this acetic acid solid was dissolved in a water, and what is the total volume of this liquid? Okay, when a solid dissolves in a liquid, the solution looks liquid only for outside eye. Okay, so what is the total volume of this liquid that I call it as a solution? It is 100 ml. Okay, right? So in 100 ml, how much of acetic acid is there? You know, it's 5 gram, right? Usually, where do you use this term? In case of medicine, guys. Most of the tonics, okay, all that medicine that you drink, you know, most of them are liquids, but actually how they are prepared? Some solids that they mixed up with some liquids and they made it as a solution. Okay, and if you want to know how much of solid has been there in that 100 ml of solution, okay, then this particular term is used here. Okay, so if I have to give the definition of this particular mass by volume percentage, then how do I define? It is the amount of substance, okay, which you are measuring in grams, okay, dissolved in 100 ml of solution. So solution you are measuring it in volume, solute you are measuring it in mass. Okay, if that is the case, you will use this mass by volume percentage. So what is the formula for mass by volume percentage here? Same thing, mass of solute, because solute you are measuring in grams, no, which you call it as mass. So mass of solute, right, divided by volume of solution, because solution you are measuring it in ml, so total volume of solution multiplied by 100. So this is the formula that we use, guys. Okay, say suppose if I mention 5% acetic acid, what do you mean by 5% acetic acid? It means 5 grams of acetic acid, 5 grams of solute is there in 100 ml of solution. 100 ml of solution. Okay, or in other words, you can also say it as, okay, let me write another meaning here. You can also say it as, very important, 5 grams of solute is there in 100 minus 5, if you do 95. So that means 95 ml of solvent. Okay, so how much of solute is there? 5 grams. But how much of solvent is there? It is 95 ml. Okay, solution is always, it's a combination of solute plus solvent, remember. So that is about mass by volume, guys. Okay, so now coming to volume by volume. Suppose if both components are liquids, okay, so when both components are liquid, then we use volume by volume percentage, guys. Okay, so how do I define volume by volume percentage? Here is very simple. Volume by volume percentage, no, it is the amount of, it is also same thing, amount of liquid, or sorry, let me write it as solute only, amount of solute, you are measuring it in ml. Okay, so we have considered volume for solute, we have considered volume for solution or solvent also. Okay, so the amount of solute we are measuring it in ml, dissolved in 100 ml of solution. 100 ml of solution is called volume by volume percentage. So what is the formula you will write? Volume of solute, because you are measuring it in ml, volume of solute, and the solution also you are measuring it in ml, so volume of solution, okay, multiplied by 100. So when two components are liquids, then we use this concentration term. Okay, so hope you understood. So now let us solve few questions. Okay, so there are certain problems here. So when you solve a problems, you will understand in a better way, like how to apply this concept, where to apply and everything. So always I recommend you to practice more and more problems, expose to more and more questions when you study such concepts, because solving problems will give you better understanding and better applicability mind, better thinking it will give. Okay, so now here we will solve some problems. Okay, yes.
See guys, you also open your NCERT textbook. Let's solve these questions 1, 2, 3 which are there on concentration terms. Okay, yes. So the very first question, look at here, a common talcum powder, that's a face powder that we apply, right? Talcum powder contains 4% M by M zinc oxide. So talcum powder has got 4% zinc oxide. So I'm just writing the formula of zinc oxide here. Okay, yes. Which acts as an antiseptic. So this will act as an antiseptic. It is actually good. Okay, it will avoid all the infections and all of that to make it happen. But too much of it is not good. How much zinc oxide is present in 300 grams of talcum powder? So total talcum powder, how much you have? Total mass of talcum powder. Total mass of talcum powder is how much? Okay, it is 300 grams. That means it is a solution. Total mass of a solution is 300 grams. Okay, how much percent of zinc oxide is there? They have given 4% and they are asking how much amount of zinc oxide is there. You can't say it is 4%. So this is there in percentage form. Okay, they are asking you the mass of zinc oxide, how much is there. Okay, so there are two ways of doing this problem. Okay, say for your board exams or for your exams, they want step-by-step answer. No, you have to use a formula and show it. But quickly, the moment you see this 4%, you can find out how much is the answer. Yes, what is the meaning of 4% M by M? I told you just before, isn't it? Say for example, the moment you see 4% M by M zinc oxide, it means 4 grams of zinc oxide is there in how much? 4 grams is there in how much? It is there in 100 grams of solution, isn't it? So that is what the meaning. Okay, in 100 grams, how much of it is there? 4 grams is there. But total mass, how much? 300 grams. So 4 grams is there in 100 grams of solution, right? So now in 300 grams, how much of it is there is the question mark. Okay, so in 300 grams, how much of it is there? Just a cross multiplication. How do you do the cross multiplication? 300 into 4 divided by 100. So 1s are 3s are. So 4 3s are 12. So 12 grams is the answer. So this is the logical way of thinking, keeping a concept in mind, isn't it? So of course, in your exam, they will expect you to write the formula and etc. No, that method also I will show you. Okay, so first, let me write the given information. Okay, so what is the mass by mass percent of zinc oxide given? It is 4%. And here in the question, they have given mass of solution. They have already given mass of total talcum powder. Total talcum powder is what? The solution. Okay. So mass of a solution is 300 grams. What they are asking you? They are asking mass of solute, that is zinc oxide, how much? So what is the formula? M by M percent is equal to mass of zinc oxide here, that is a solute, divided by mass of solution. Okay, so multiplied by 100. Isn't it? So now this M by M percentage, this is given how much? 4%. 4% is equal to, numerator is question mark, denominator they gave how much? 300 multiplied by 100. Okay, so just rearrange this and calculate. right? So how do you rearrange? 300 into 4 divided by 100. If you do, you'll get the same answer, that is 12 gram. So this is the way of doing using formula, but you should know this thinking also, okay? Like I have told you in the previous page, yes, you should know how to think this way, and for exam purpose you should know how to apply the formula, okay? Yes. So that is about the question number 1, guys. So now question number 2. So this is also very interesting. Your mother gives you a bottle of orange juice concentrate to mix with water and serve it to your visiting friends. Okay, so these days in the market, what is available is orange juice concentrate. So few spoons you will take and you will mix it with water. So it becomes a drink to drink, isn't it? So you can give it to the friends. So what your mother said is, she has given a orange juice concentrate mix and she told you to mix it with water and give it to your friends. And she asks you to mix 2 tablespoons of concentrate with water. So she said, take 2 tablespoons from the original concentrate bottle and mix it with water, she said. And if each tablespoon measures 15 ml and you make 150 ml of juice per person, what is the percentage volume by volume of orange juice concentrate in the mixture you prepared? Okay, so what is given here? Each tablespoon has got 15 ml of concentrate. Okay, so let me write it here. So 1 tablespoon. So 1 tablespoon has got how much? 15 ml of orange juice concentrate. Okay, concentrate means this is the solute here. This is the solute here. Okay, and you are making how many ever glasses it may be, but 1 glass. Okay, 1 glass. 1 glass means how much of water you have taken. So how much of total juice that you are making? 150 ml. Okay, so this is the solution that you have. So this is the volume of a solution. 1 glass of juice you are making. Okay, and they are asking you calculate volume by volume percentage. They have given volume of solution, isn't it? Okay, this is the volume of solution, isn't it? So 150 ml is the volume of solution and 15 ml is the volume of solute. So what is the formula? Volume of solute divided by total volume of solution, and you will multiply by 100. But volume of solute, 1 spoon has got 15 ml, but to make 150 ml of a juice, how many spoons your mother told you to add? 2 spoons. Isn't it? So if you take 15 in the numerator, it is wrong. Your mother told you to take 2 spoons. So 1 spoon has got 15 ml, 2 spoons has got 30 ml. So what is the calculation you have to do? 30 divided by 150, that is volume of solution is 150, you multiply by 100. So if you do this calculation, you would get the answer. So you do the calculation and tell me what is the answer you got. Okay, so that is about the second question here. So now coming to the third question. What they said is vinegar, which is used as food preservative and additive, contains 5% volume by volume acetic acid. So the vinegar that you use for your foods, it is 5% volume by volume. Okay. Glacial acetic acid is a liquid. So how do you prepare this 5% volume by volume is? So that the number, what does this number mean here? What does that number mean here? 5% volume by volume. What is the meaning of this number? 5 ml of acetic acid, 5 ml of acetic acid is there in 100 ml of solution. Okay, this is what the meaning, isn't it? It is there in 100 ml of solution. That is the meaning. Okay, what they said is 5% of glacial acetic acid is liquid, that is 100% acetic acid. So to prepare vinegar, you will use glacial acetic acid, which is 100% acetic acid. Okay, from that you are taking 5 ml. That's what the meaning of 5%. If you want to make vinegar from glacial acetic acid, how much would you proceed? Same thing, 5 ml. That is what it means, isn't it? So they have given 5% already. So what they are asking you is how much ml of acetic acid you will take from pure and then add it to remaining amount of water to make a solution. That's what they are asking. So very simple here. Okay, so you are taking 5 ml of pure acetic acid, okay, acetic acid, and you are mixing it with 95 ml of water, isn't it? So when you mix it with 95 ml of water, you are getting 100 ml of solution. That's it. So how much of a pure acetic acid that you are taking? 5 ml you are taking, you are mixing it to 95 ml of water, and that is giving you the 100 ml of the solution. Okay, so that is all about the third question, guys. So guys, now let us talk about another very interesting and important topic in chemistry actually, as far as solutions is concerned, that is solubility. Okay, so you have to understand about solubility in a best possible way, and I'll try to explain my level best to make it as simple as possible. And after listening to this concept, and you have to tell me whether you got that feel of understanding or not. Okay, fine. So before even I begin with the definition of solubility and all, I would like to talk about two types of solutions based on solubility. It is based on solubility. Solutions can again be classified into two types. Number one, saturated solution. Okay, the other one is unsaturated solution. So it's very important to understand the meanings of saturated and unsaturated, guys. So what is saturated solution? So I'll show it in the form of a picture. Look at here. So here you have water. Okay, so a beaker of water, say up to 80 ml. Okay, and what is mixed here is a salt. Okay, so we know salt is a solute here because definitely it is there in a small amount, and water will behave as a solvent here. Okay, so now I added salt, spoon after spoon. I kept on adding salt and I am dissolving in this particular 80 ml of water. Okay, so one spoon I added, I stirred it, it dissolved. Second spoon I added, it dissolved. Third spoon I added, dissolved. But the fourth spoon that I added is not getting into the water. Okay, so it is not at all dissolving. The limit of salt getting into water got over. The limit is over. So that extra salt or the extra solute that I added, see, it is settling in the beaker in the form of a solid. Okay, so salt is there as it is. It is not going into water. It is not getting mixed up with water anymore. Okay, at this particular temperature. So the entire mixing process I am doing at some room temperature, say about 26 or 27 degrees centigrade. Okay, so at this room temperature, when the temperature is constant, okay, so I am trying to dissolve salt in this water, spoon after spoon I am adding, but there comes a point where the no more salt is getting dissolved. Okay, so the maximum limit of dissolution, okay, the capacity of a salt getting dissolved in water is over. Okay, so such a solution is called as saturated solution. So saturated means the limit is over. Above this, you cannot add any salt. If extra salt is added, all of that will not dissolve. It will settle at the bottom of the beaker as it is. Okay. So now, what is unsaturated solution? You added 1 spoon. Okay, it got dissolved and there is a scope for second spoon to be added. There is a scope for second spoon of salt to get dissolved. Okay, so still some vacancy is there in this solution to add a solute. Okay, so such a solution is called as unsaturated solution. So unsaturated means there is still a vacancy in a solution for a solute to get dissolved. Saturated means there is no further vacancy for a solute to get dissolved. Okay, at a particular temperature, at a fixed temperature. So this is what we mean by saturated and unsaturated. So now coming to a point, what is solubility here? Solubility is nothing but the capacity of a solute to get dissolved in a particular amount of solvent at a given temperature is called as solubility. Okay, solubility is all about the capacity. It is the ability of a solute. Okay, so now I will write the definition for you. Very important, note it down. It is the ability. Okay, so it is the ability of solute to get dissolved, okay, in a given amount of solvent, very important, at a specific temperature, okay, is called as solubility. Take a screenshot of this definition, very, very important. Okay, so now one more very interesting concept. Suppose if I increase a temperature, okay, so if I increase temperature here, say I am heating this, okay, so what am I doing this? I am heating. So when I heat it, will again some amount of salt which left undissolved, no, that salt can go into water mixed up very nicely, isn't it? So maybe some amount of salt again gets mixed up if you can increase a temperature, isn't it? So what I can say here is, as temperature increases, the capacity of a solute to get dissolved in a solvent also increases, even if something is excess at that particular point. Okay, right? So this is a very interesting point. Okay, so as your temperature increases, here T for temperature, as temperature increases, your solubility also increases. Okay, so this is very, very important, and this is true when solute is solid and solvent is liquid. Okay, so we are dealing with what kind of solution? Solute is usually solid and solvent is usually liquid. For those kinds of common solutions, this is true. Okay, as you increase the temperature, solubility of a solute, the capacity of a solute to get into a solvent also increases. Okay, very, very important. So now in your NCERT, there is a graph. Okay, we will understand what is that graph and etc.
Look at here, guys. So under the solubility concept, look at here. Okay, so we can actually study how solubility increases as temperature increases with the help of this graph. Okay, so we will always plot a graph of solubility. So this is a solubility value on y-axis, and when we take temperature values on the x-axis, no? Okay, so there are two compounds here. So we are studying the solubility of two compounds. So here actually we are comparing two compounds, two different solutes we are comparing, because different solutes will behave differently. Say salt getting dissolved into water as temperature increases is different from sugar getting dissolved into water as temperature increases. So different solute dissolution also is different. Okay, so here I took a solute B and I took a solute A, and I am studying their capacity to dissolve. That's what we mean by solubility as temperature increases. So I am just studying here how their solubilities are increasing as temperature increases. Okay, so when I put a graph for both compounds, look at here, compound A solubility is increasing but not very great, isn't it? See, the solubility is 50 at temperature 10 degree. Solubility is just above 10. That's it. Very little increase you will see at the temperature 20. Solubility has increased very small at the temperature 30. Okay, so if you see for compound A, yes, solubility is increasing as temperature increases, but here it is very little increase. You are seeing the increase is to very small extent. Okay, but if you look at compound B, look at here, the solubility was around 180 or something at 10 degree, but here the solubility is around above 200 at temperature 20 degree, at temperature 30, but at temperature 70 degree, if you see, the solubility was almost above 330 or 320, isn't it? So here the solubility is increasing more as temperature increases. That you can observe with compound B, but solubility is very slowly increasing with compound A. So what it tells you is, here you need to understand different solutes behave differently. Okay, they all soluble, every solute solubility might increase as temperature increase, but look at compound B's very good increase, but here not very good increase. So what it tells here is different solutes behave differently. That is what they are trying to tell you through this graph. Okay, that's it. So now if you want me to solve few questions that are there in solubility, let's observe. So the first question, it is based on the graph only. So let me just go down. I want you to see the graph also. Okay, so now let me solve the questions here. Okay, the solubility of a compound A in water at 20 degree. Okay, the solubility of a compound A at 20 degree, whether this is less than or more than or similar to solubility at 60. So what is the solubility at 60? Solubility at 60 is around maybe 50 or 60. Okay, solubility at 20 is below 50 only. So obviously the solubility of a compound A in water at 20 degree is less than the solubility of a compound at 60 degree, because as temperature increases, solubility should increase. So 20 degree means lesser temperature, so solubility will be less. 60 degree higher temperature, solubility will be more, definitely. Okay, then next question, the solubility of a compound B at 20 degree is also less than the solubility of compound B at 60 degree. At 60 degree more solubility, is 20 degree less solubility. Okay, now third one, the solubility of dash increases more than that of dash with the increase in the temperature. So compared to A and B, whose solubility is increasing more? Yes, definitely the solubility of compound B increases more than that of compound A, okay, with the increase of temperature. That's it. Okay, so now solubility is over. So the next topic is the methods of separation of homogeneous mixture. Very interesting. So how do we separate two components from the solution? Solution is the best example for homogeneous mixture. So where components are nicely mixed up, but if you want to separate one component from other, if you want to separate a solute from a solvent, what are the techniques, what are the methods that we are supposed to follow is what we are going to study next, and all of those methods I will explain in the next video. Okay, so hope you have enjoyed the video. If you have enjoyed the video, at least one point if you have got clarity on, I deserve a like button, isn't it? So homeschool deserves a like button from all of you. If you have not yet liked after coming to this much, this far, then it's not good, right? So please hit a like button. Why am I asking you to hit a like button? Because it can reach so many students like you. Okay, let everybody gets its benefit, right? So hit a like button once again and share this video to all your classmates and for all of them who are in need of this syllabus and this chapter. Okay, thank you so much. See you in the next video with methods of separation. Okay, that's going to be really interesting video. Okay, so watch it without fail. Thank you. See you soon in the next video then.